Thank you. Let me start with a couple, this is loud, couple intros. First, if you're sitting in the back, I am not very good at I try to pack too much into my slides and they end up too small and you're gonna have trouble, and so there are a bunch of seats in the front if you want to be able to see the slides. I encourage you. We've got 4 seats in the front row and there's a few others on the sides. If you came here to see a talk about synthetic controls, which was on one of the first posters, I apologize. I ended up switching because it didn't seem like the right talk for the audience, but that's not what you're going to see today. Okay, so this is a project that started out as started out in the kind of service side of my portfolio as a professor, not in the research side. I was called up by various people on campus who said, hey, we've been doing we've made some changes to our undergraduate admissions. There's some debate about whether it's good or bad, and can you help us figure that out? And so that's where this started. I want to acknowledge Greg Dubrow here from the admissions office, who's been a big kind of partner throughout this process, helped me figure out, helped on the data, helped design the study. So that some of what I'm going to present to you is from that initial study, and then some is going to be some analysis that I've done since that initial study, which had about a 1-month turnaround time, and so we didn't have that long. But since then, we've gotten the text of the letters themselves, and that'll be some of the analysis we look at. So the basic question comes from the kind of mandate I got when I was pulled into this, which is we started asking for letters of recommendation. We did it because we thought that as Berkeley is getting more and more selective at the undergraduate level, we're asking readers to do what's called holistic review, which means there's no formula that they use to weight the SAT plus half of the GPA and then admit people. They look at the whole application and try to make a judgment. But the whole application, if you're only selecting 5% of the applicants, it's really hard. If the whole application is just a bunch of numbers, it's really hard to make textured judgments. And they were feeling like they didn't have enough information to be able to make the decisions that they needed. They thought that they would do a better job of identifying particularly students from underrepresented backgrounds if they could get more information from the students. And so they decided to ask for letters of recommendation, ask the students to submit them, and with the hope that would give people a little bit more information that wouldn't show up in the things that even went into the holistic review process, and would have helped them make the distinctions and identify the students who, even though their numbers might not be quite as high as other students we admit, they'd overcome real barriers, and it was a good person to admit. So that was one view. There was a group at UC Office of the President who took a very different view, which was this was clearly going to hurt underrepresented applicants' admissions chances, because all of the very advantaged students can ask their friend the senator to write them a letter of recommendation, and the students from underrepresented backgrounds don't have somebody who can write them a good letter. And so they took the approach that this was going to be bad. To my mind, that's what makes a good empirical question, when it's not obvious what the answer is. And so I'm not sure that I would have proposed this ex ante as a way of finding out the answer to this question, but since this campus was already doing the study anyway, might as well try to learn something from it. And so that's the idea here, is to try to figure out whether the letters of recommendation helped or hurt students from underrepresented backgrounds. So the way I'm going to kind of do this is I'm going to spend some time talking about the admissions process and where the letters fit in. And then I'm going to present kind of 2 sets of estimates. I'm a labor economist. We kind of do what we call program evaluation, trying to kind of come along and evaluate some program after the fact. I teach a course on this, evaluate it after the fact, and try to assess the overall impact. And so I'm going to show you some estimates that take kind of a program evaluation perspective on what the effect of these letters was. But then after that was the kind of initial analysis. But then I got the text of the letters. And I thought this was a really interesting chance to try to use the text of the letters to come up with a better measure of whether this claim that underrepresented applicants might be getting worse letters, whether that was true. And so I'm going to do some natural language processing. It's going to turn out that I'm going to run into the same challenge that comes up over and over and over again for people in my area who are trying to figure out how to use machine learning type methods, is that machine learning type methods are really good at prediction. And it's not as easy as it seems like it ought to be to integrate that prediction approach into a program evaluation approach. And so we'll see that there's some, it's not clear to me how much I'm learning yet from the letters, although I think there's more work to be done here. Okay, so we'll go through this. And I should say the norm in economics is that I should have been interrupted 3 times with questions by now. And so I would encourage people, raise your hands as you go. I'll leave some time for questions at the end, but I get nervous if I don't get interrupted along the way. Okay? Okay. So the way the process worked, and I'm going to talk about the way it worked in 2016-17, although most of this is pretty similar in other years. Applications are submitted in November. The system opens up on November 1st and closes on November 30th. Okay? We get, I think, 80,000 applications a year. So it's a big number that pour in. You apply to all the, there's one application for the whole UC system. You just check off boxes for the ones you want to apply to. And there's a fee for each one you want to apply for. Okay. Each of the campuses runs its own admission system. There's then a process at the end. If you're what's considered eligible for the UC system, you're supposed to be guaranteed admission to a UC campus. If each of the campuses independently decides not to admit you, then there's a process at the end to figure out who's going to take you. But that's basically never Berkeley, and so that's not really relevant for Berkeley admissions. Okay, so we get the applications. We have a system that was implemented about 10 years ago called holistic review, where there's no formula, there's no guidelines about what it is, but the 2 application readers get your whole application. There's a kind of summary sheet that has all your numbers, SAT, GPA, characteristics of your school, some family background measures, some other aspects of you, what extracurriculars you're in, kind of the key summaries that you might think are relevant for admissions. They also get your essays. They get everything about you. They score that. And as of a couple years ago, the way they score it is they give it one of 3 scores, a yes, a possible, or a no. Each of them gives, yeah.
So does prospective major play any role in this?
It does. That's on there. But for now, basically at this stage, I think they're just scoring yes, possible, no, without independent of that. Putting a little more weight maybe on some characteristics if you're going to be a chemistry major than if you're going to be a literature major. But but it's pretty informal how they do that. There's no systematized way of doing that. And Greg, feel free to correct me if I'm getting aspects of this wrong.
For freshman, major matters. For chemistry and engineering colleges, it doesn't matter for any of the other colleges.
Okay.
And we look a little more for math prep and interesting
Right.
science.
Right. But college matters. So that college.
Chemistry and engineering.
Yeah.
We don't.
Okay. Okay. So the 2 readers score it. You then have a set of one of 9 possible scores. You could have 2 yeses. You could have a yes and a possible. You could have 2 nos. At the end of the process, it goes to the admissions office, who then makes a decision, who then divides up the candidates into pools based on colleges and sometimes majors, and then kind of figures out how to admit. They first admit the yeses, and then they kind of work down the list. There's some tie-breaking procedure that may happen because it may be that since there are only 9 cells, they're going to have to take part of some of those cells, and there's processes for figuring out which part of those. That's not going to be relevant for my analysis. They don't see. I'll explain why. Okay. As of a couple years ago, we piloted a new program of asking for letters of recommendation. The initial campus decision was to ask for them from everybody as part of the application. You got pushed back. The compromise was that instead of asking for them as part of the recommendation, we would do as part of the application, we would do an initial review of the applications. We would assess them into yes, no, possible. For the possibles, we would then go back and invite them to submit letters of recommendation, with a message that said, if you don't submit them, it won't hurt you, but this is a chance to give us some more information. Turns out that in order to make the timing for all that work, you basically have a week and a half to assess whether somebody's a possible to invite that decision. There's no way they can actually get through all the first reads in that week. And so they basically apply a statistical model to predict whether somebody's likely to be a possible, and generated a bunch of requests to be requested for letters. So in 2016-17, about 18,000 students were invited to submit letters of recommendation. Okay, they're allowed to submit them. They have until I think late January to submit them. If they come in, the first reader will be done by that point, so they read without the letters. The second reader, if the letters come in, gets to see the letters, and can incorporate that into their score. Okay, yeah.
Is that 10,000 the proportion that actually ended up voluntarily submitting letters, or was there some?
No, it's quite a bit higher than quite a bit higher than 10,000. But we give me just a second. Okay, so yeah, let me just explain that. So in 2016-17, what we decided to do is we wanted to estimate the impact. And the suggestion I had, I knew that this was a machine that had to process 80,000 applications in a very short period of time. I couldn't touch that machine at all, risk breaking it. So what we did instead is we asked some of the application readers, when the process was done and they were about to be laid off and kind of sent home for the summer, we asked them, can we pay you and you stay around for a couple more weeks and read more applications? And so we had them read more applications. We gave them the same applications again, not to the same reader, but to different readers. But this time we had the applications without the letters. And we asked them to score just the same way they would have done as second readers if they didn't have letters. And that way we can compare what I'm going to call the third read without the letters to the second read with the letters as kind of a within subject design on the effect of the letters. Okay, and let me just say, to answer your question, the 10,000 was just, that was the budget we had for the third reads. So we picked basically a random sample of the 10,000, somewhat overrepresenting underrepresented applicants.
But what was the proportion of the 18,000? I'm really interested in choosing to.
It ends up being about 85% end up submitting 2 letters. Yeah.
And the readers, or say for the 10,000 applications.
Yeah.
They were experienced readers, so they knew what they were doing.
Exactly. These were all people who had already been through the system for the regular.
They had personally had worked out how they deal with these and so on and so forth.
Yeah.
And so this number is so large that they're looking at, there's no memory of individual applications.
Well, we were very careful to make sure that they never got an application that they had personally seen previously. Because you're right, they probably wouldn't remember, but we didn't want to take a chance that they would have. So what we tried to do is assign the third reader applications from the same region of the state that they had read as second readers, but not the same students. Yeah.
That's right. R1 is the same person then, from R1 at the top and R1.
So they're basically, for this study, you can think of there being 3 rounds of readers. It's often the same people, but our application will be read by R1, which is one of a bunch of 100 people who reads the applications initially, never has the letters. R2, if the student submitted letters, gets to see the letters. And then R3 is, again, all the same batch of readers, but shuffled around among them. R3 doesn't see the letters, even if they were submitted.
And R3 readers are aware that this does not bear on attention.
Yeah, we did our best to kind of instruct them to read in the same way that they would have, but there was no way to make this double blind. They had to know that the process was kind of over and this was part of a study. Yeah.
So the students who are invited to submit the letter, the likely possible, should we think of them as being kind of like in the middle of the distribution, not very likely to get in and not like very unlikely to get in?
I'll show you some evidence on that. It turns out actually they're pretty representative. That the model we had for identifying the likely possibles was not that good of a model in terms of kind of very narrowly targeting. And so it ends up being pretty representative of the full range. Okay. Okay, so key variables to kind of think about. I'm going to be focusing on a binary measure of whether somebody's an underrepresented applicant, where there are 4 categories that make you underrepresented. And this was kind of taken from what the admissions office thinks of as the categories that they're thinking about. One is whether you were eligible for a fee waiver, which meant you didn't have to pay to apply. That was kind of the best proxy they had for being a low-income family. Another is if you went to a very low test score high school, which corresponds to a high poverty high school. Another is if neither of your parents went to college. And another is if you're from an underrepresented racial or ethnic group. That one ends up getting treated a little bit asymmetrically in the process because by law we're not allowed to consider that in admissions, but the other 3 are. So the readers can see these 3 measures when they're looking at the application, but they can't see the underrepresented applicant. You might think they can probably infer it if they know what high school you went to, and you might not be wrong there, but officially they don't know the I believe they see the names, right?
Yeah, names are on the application.
Yeah.
For many students, they can tell gender and race.
Yeah.
and ethnicity.
Yep. Yeah. I would not be, again, if you think they probably have a good idea of that, you're right, but officially they don't know it and they're not considering it. Okay. And then the other variable I'm going to construct is it's really helpful to be able to distinguish between applicants who have a shot at getting in and applicants who don't. And an awful lot of the people who apply to Berkeley are people who are really planning to go to Santa Barbara, but it's free to check off another box, and so they apply to Berkeley. But their chances of getting into Berkeley are quite low. And so I'm going to construct what I call an admissions index, where basically I take the 2015 data, I run a regression of whether you're admitted on all of the kind of quantitative measures I have on the application, and I construct a predicted probability of being admitted. And this is just a rough cut as a way of distinguishing between the people who are clearly not going to get in and the people who have a pretty good shot of getting in. Okay? So here's the distribution of that admissions index among applicants. It ranges from 0 to 1 because it's a probability of admission. And I've got it separately for applicants from underrepresented groups and not from underrepresented groups. You can see for both of them, the bulk of applicants have very low chances of getting in based on the numbers. A few of them might get in, but most of them are likely not going to get in. That's a larger share of the applicants from underrepresented groups than from non-underrepresented groups. This is why these groups are underrepresented at Berkeley, because they tend to have lower admissions qualifications by the standard measures. But they both have kind of a long tail, and there are some students who have 60 or 70 or 80% chances of getting in based on just the numbers, but they're a minority of applicants. Okay? Here's what it is when I limit it to the 10,000 people who are basically a representative sample of the people who asked for and submitted letters. It's not quite as concentrated at the bottom, but we still have the bulk of the applicants who I have these double reads for have very low admissions probabilities. There's then a longer right tail. Okay? Yeah.
And either in the predictions you're using here or in this direct analysis, there's nothing about the actual acceptance.
So for the data I'm using here, I'm not going to be focusing on actual acceptance. I'm going to be focusing on the reader scores. There's then a process that the reader scores get turned into acceptance, but because the letters aren't visible to the people who are, when the people are making the decision about accepting, they don't see the letters. I'm not going to consider that as a separate.
Nothing from your prior year estimates would bear on acceptance.
Exactly. Yeah, the idea is that if it affects the readers, the way it affects acceptance is by affecting the reader scores. Okay. And there was also kind of no way to do it within subjects designed for the acceptance decision. So I thought it was better to focus on the reader scores where that was possible. Okay. Summary statistics. This is one of the first slides that you guys can't possibly see, so I apologize. But roughly, I don't know what's important. Of all applicants, about 36% were invited to submit letters. Of those, the way you responded to that request is you were asked, enter email addresses of 2 people who will write you letters into our system, and we will send them an email requesting a letter. So we can tell whether the student invited somebody to submit a letter because they gave us their email addresses. Of the 36% who were invited to submit letters, 27% requested them. So I was wrong. It's about 3/4 requested the letters. And then of those, basically everybody who requested letters, we got letters in. So it was very rare that somebody requested a letter and we sent out an email saying, please send us a letter, and then we didn't get one back. But it was not so uncommon that a student was invited to submit a letter and then they didn't. And then they didn't invite somebody to submit one for them. And that was much more common among underrepresented applicants than it was among not underrepresented. Only about 2/3 of the underrepresented applicants who were invited to submit letters did so, and closer to 85, 90% of the non-underrepresented applicants.
So part of the reason could be that the students in the underrepresented group are less likely to be applying to private colleges and universities, which they often more likely to be asked for letter information, so they don't have them ready, right?
That's quite possible. And so one of the ways in which this policy could hurt underrepresented applicants is if the non-underrepresented applicants, they already had people who'd written letters for them, and all they had to do was just click send again. And the underrepresented hadn't done that, and so it would have been a bigger hurdle. Okay, so that's the basic setup. Let me talk about kind of what I think of as a program evaluation perspective. You could also think of how do you evaluate this program without the access to the letters themselves. I'll show you the results from that, and then I'll get into the natural language processing, which I think is maybe, if I understand who comes to these talks well, that's probably of more interest to this crowd, but maybe I'm wrong. Okay, so I'm going to break it into 2 stages. The first stage is looking at disparities in whether people submit letters when they're invited. And the strategy there is just going to be to take that basic summary statistic I just showed you and try to understand which students it was. And the result there is going to be that there are disparities. As we saw, the share of underrepresented applicants who submit letters when invited is much lower than for non-underrepresented. But the disparities are concentrated among students who are pretty unlikely to get in any case. They're the very low admissions index people. My interpretation is that especially if you have a fee waiver, but even if you don't, the only thing it takes to apply to Berkeley if you're already applying to other UCs is just checking a box. A lot of people check that box, But then if we're actually going to require them to do some work and get a letter of recommendation to do the application, they know they're not going to get in anyway, they drop out. So there's going to be that is going to create some disparities, but it's not enormous. And then the second piece is, among the people who submit letters, does the letter seem to help one group relative to another group? And the strategy there is going to be to use this within subject design, where I have a reader score with the letter and a reader score without the letter, and ask who gives the student a higher score, and how is that different for underrepresented and non-underrepresented. And the result there is going to be that when the readers who have access to the letters are more generous to everybody, which could be a problem with the way we kind of calibrated the readers on this third round. We tried to get them to maintain the same standard they were maintaining before, but they might have raised the standard a little bit, because it's very hard to calibrate when they're not getting a fully representative set of applicants to look at. So the mean difference is hard to interpret, but it looks like the difference between R2 and R3 is bigger for the underrepresented applicants for the non-underrepresented applicants, which looks like evidence that the letters, when you submit them, had the intended effect of allowing students to reveal obstacles that they'd overcome that might be relevant to the admissions office. This effect turns out to be larger than this effect. So the net effect is going to be that the letters look like they raised the share of admitted students who were from underrepresented groups by a very small amount. Okay, so let me just walk through that, and then we'll get to the natural language processing. Here's what this graph shows is in 2015, which you can focus on the 2016, which is more relevant for this talk. What I have here are circles representing the non-underrepresented applicants. I broke them into bins by the admissibility index, and I showed the share of students who submitted letters. And you can see for non-underrepresented students, roughly 90% of them throughout the distribution submitted letters when asked. Okay, there's some variation around that, but it's pretty high throughout the distribution. For the students from underrepresented backgrounds, it's a little lower throughout the distribution, but it's a lot lower at the bottom of the distribution, where most of the applicants come from. So in the middle of the distribution, it's kind of 80% rather than 90%, but at the bottom, it's 70 or 60 or 50%. So it looks like the weaker applicants from underrepresented groups were less likely to submit letters when they were invited to do so, which again, could be that these are students who weren't applying to private colleges and so they didn't have letters ready. It could also be that these were students who weren't all that serious about coming here, and once there was a cost, they decided to drop out.
So if this is a dumb question, what's a point on this plot?
A point represents, I believe it's 1/20th. Wait, I took all the applicants from each demographic group, so underrepresented, not. I divided them into 20 bins by their admissibility index. And then each point represents the average admissibility index and the average share that submitted letters from that. So it's a version of a kind of non-parametric regression of the fraction submitting letters on the admissibility index that gives you a little bit of a sense of where the density is. That's what economists call a bin scatter plot, but
Okay,
we could.
my question is
Okay.
Okay.
Okay, so what this represents is that 20% of the underrepresented applicants had admissibility indices below about 0.05, and among those, half of them submitted letters. Half of those who were invited submitted letters. Okay. So now let's get to the study sample. This is the 10,000 applicants who we were able to use. We lost a few because kind of for data problems. Basically, the 10,000 applicants for whom we had double reads, once with the letters and once without the letters. 60% of them came from underrepresented groups. Average GPA was a 4.2 weighted. These are not weak students. But again, 4.2 is not that high among our applicants. The SAT average 1,700. 5% of them got a yes from the first reader, 20% of them got a yes from the second reader, and 13% got a yes from the third reader. Okay. This shows the concordance between the scores among the reader 2 is the one who had the letters, and the reader 3 is the one who was trying to replicate the process but without the letters. You can see that they agree more often than not. The diagonal is bigger than the off diagonal. But there's a lot of variation among that. I think most of this is just that the inter-rater reliability of these scores is not that high. If you gave two people the same application and had them read it, they wouldn't give you the same score every time. But it is true that these are reading somewhat different applications because the reader 3 has the letter, reader 3 doesn't have the letter, and the reader 2 does have the letter. You can see on here that the below diagonal has bigger numbers than the above diagonal. This is, the reader 2s are a little bit more generous than the reader 3s. They gave more yeses and more maybes. Okay, but that's the basic data for this. And then the question is, how does this vary for the underrepresented applicants and the non-underrepresented applicants? The basic idea is just, does this reader 2 minus reader 3 difference, that's the benefit you're getting from the letters, also contaminated a little bit by potential differences in the calibration, but that's the benefit you're getting from the letters. Is it different for underrepresented and non-underrepresented? And here's the table that shows that among all the 10,000 applicants, about a quarter of them were scored better by reader 2 than by reader 3. 60% were scored the same, and 15% were scored lower by reader 2 than by reader 3. And so if you take the share who scored better minus the share who scored worse, about 10 percentage points of the 10% of the students benefited from having the letters, roughly in this 3-point scale. That's a little bit lower for the non-underrepresented students than it is for the underrepresented students. So 9% of the non-underrepresented students benefited, 11% of the underrepresented students benefited. Yeah?
Do you have any data on the demographic characteristics of the readers? Whether there's any sort of match between the reader and the applicant?
So what we know about the reader is we know the student was asked, what's your relationship with this reader? And so they said, most of the answers are things like teacher, counselor, coach, but we don't have the race or gender. We have the names in principle, although I don't have the names.
The raters.
The raters. Oh, I'm sorry. Sorry, I misunderstood. We do, although the IRB was very concerned that I would know who the readers were, and so I could probably figure out a process to get the demographics. The demographics in general of the readers is a pretty racially diverse group, much more so than our students, for what that's worth. But I don't know the individual identities. I guess I have an identifier for each one, and so I could do some with that. Okay, this is one way of measuring it, of whether you score better when the reader has the letters than when they don't, or whether you score worse. The problem is one way to score better is get shifted from no to possible, or possible to no, and if you're out of the money anyway, it may not matter. And so another way to measure this is to look at the share who get yeses. And so that's what I have over here. Overall, reader 2 gave 19% yeses, reader 3 gave 13% yeses. So 6% more yeses when they had their letters than when they didn't. That's bigger for the underrepresented students, 18 versus 11, than it is for the not underrepresented, 22 versus 16. So overall, it looks like the readers were more generous to underrepresented students when they had the letters than when they didn't, relative to how they were with the non-underrepresented.
This may be coming, but
yeah.
How much statistical uncertainty is there in these numbers, given the difficulty with interrater alignment?
There's not much with 10,000 observations, the overall aggregates are pretty precise, even though there's a lot of variation among them. I mean, this is just a binary variable. So we could probably in our heads work out the standard errors on that, but there's not much uncertainty. Okay. So basically all these differences are statistically significant. You can break this down among students of different admissibility indices. And basically it looks like the readers were more generous to these kind of moderate, the letters were most beneficial for students who had admissibility indices in the kind of 10 to 20% range. And the letters made less of a difference if you were already going to get in anyway. The letters didn't make much difference. If you already weren't going to get in anyway, the letters didn't make that much difference. Where they seem to make a difference is right in the kind of, again, this 10 to 20 range or 20 to 50 range. And that's consistent with it helping the underrepresented students because more of them come from that range.
If the reader didn't bother, if they saw, oh, this has scores very high, why do I bother with the letters on this one, or something like that?
I wouldn't say that they didn't bother. We don't know whether they did or didn't bother, but the letters helped less. And it could be they didn't look at the letters. It could be that they looked at the letters, but they didn't tell them anything they didn't already know, or they didn't tell them anything positive they didn't already know, because they'd already inferred the best about those students. Okay, you can also do this separately, but you see that basically in every group, At every level of the admissibility index, the underrepresented students benefit more from having the letters than the non-underrepresented students do. Again, the benefit is bigger in this mid-range, but it seems to happen throughout most of the distribution. So, okay, so that is basically the program evaluation perspective. The last thing to do is add up these two pieces of it. So one piece is that the underrepresented applicants were less likely to request letters when we invited them to do so. That's going to hurt the underrepresented share. One way to kind of bound how much that could hurt is to assume that if you didn't submit a letter when you were invited to do so, then you were never admitted. That's a very strong assumption. In fact, 9% of those students were admitted. But let's assume that not submitting a letter is death for your application. Whereas if you weren't invited, then let's assume you would have been admitted at the same rate as what your admissions index says. So that's a rough estimate of how much not submitting letters could have hurt you. And what you conclude is that if you take that approach, then the fact that so many underrepresented students didn't submit letters reduces their share of admitted students from 39% to 37%. Okay, so it hurts by about 2 percentage points. Again, I think that's overestimating because many of those students were admitted anyway, but that's one way of doing it. The other piece of this, though, is that when they do submit letters, they seem to benefit from that, and underrepresented applicants seem to benefit relative to non-underrepresented applicants from that. And so it looks like if you take a yes score as roughly a proxy for you get in, underrepresented applicants were 37% of the yes scores given by reader 2, who had the letters, but only 33% of the yes scores given by reader 3, who didn't have the letters. So it looks like this effect is about twice as large as this effect. And what I conclude is that the net effect of the letters program was to raise the underrepresented share of applicants, not by very much, by 1 to 2 percentage points. It didn't seem to hurt it, but if anything, it helped it, but it's not an enormous effect. Okay, questions about that? Okay, let me move on then to the next piece of it. This is the study that I had to do in about a month because UCOP was making the decision, and helpfully they made the decision the day before I turned in my report. But in any case, the next step was we extracted the letters themselves. And this is where Greg was extremely helpful. It was a lot of work. We had to extract all the letters, which were in PDFs, so we had to kind of scrape them out to text files. Then we had to anonymize them, take the names out of them, because the IRB didn't want me to have the names. This is still re-identifiable data. You shouldn't think of this as totally anonymous, because even if we can we can search for their first name and their last name and take it out. If the letter writer used a nickname, that's still going to be there. There are other things, but that's what we did. We had to anonymize the data and take it out, and that took a while. But then eventually and then we had a lot of files that didn't convert well from PDFs. But eventually we had a data set that had for each applicant in these 10,000 the text of their 2 letters. And with X's replacing the names, and we also had the identity, the relationship to the letter writer.
And this is anonymizing both the applicant and the letter writer.
As best as we could, yes. And a lot of work trying to strip out all of the letterhead from the PDF that made its way into the letter and just focus on the letter itself. Okay? Okay, so then the question is, how can we use these letters to try to measure how strong the letters are, and whether again, the question is whether underrepresented applicants are getting weaker letters than non-underrepresented applicants. Maybe because they don't have access to as good writers, maybe because the writers are too overwhelmed or don't know what we're looking for, or something else. Okay, so there are going to be kind of 3 steps. One is going to be defining the features of the letters. The kind of approach we're going to be taking is defining a bunch of features and then taking a random forest approach to measuring the strength of the letters. So we're going to define a bunch of features. We're then going to measure the strength, and then we're going to measure whether there are differences between underrepresented and non-underrepresented students. So let's start with defining the features. We have, again, we have these text fields now that are for 2 letters per student. We have a bunch of features of the application that didn't come from the letter. We know their SAT score, we know their GPA, we know all the other things about them. But then we also have the letter writer identity, and so we coded up the most common categories: teacher, counselor, coach, priest, employer, things like that. And then we have the letters, and we took 2 approaches to measuring the feature, to kind of characterizing the letters. One is there's a standard package that seems to be used a lot in this literature called LIWC, that is kind of a sentiment analysis package, and they define basically have word counts that correspond to things having to do with achievement or things having to do with clout, and they just count the words that are in that dictionary in the letter. Positive emotions, and they have kind of word count, average length of sentence, things like that. But then we also took an approach of defining topics by hand. The LIWC is not customized for letters of recommendation. There's things that we might know about what's going to show up here that they don't know about. And so this was admittedly kind of ad hoc. We looked through the letters, looked at the kind of 500 most common words, tried to think about whether there were kind of categories or topics that corresponded to them. We came up with a few, like a bunch of the letters mentioned a science, computer science, physics, chemistry, biology. We kind of counted the number of words that fell into that bucket. A bunch of the words mentioned humanities of various kinds. A bunch mentioned languages. Any letter that mentioned Russian or French or Spanish or Chinese showed up there. Now that one is a little bit complicated because it's mixing up a couple of different things. It might be mixing up academic interest in languages with family background. But it's pretty hard to, we couldn't figure out a way to distinguish those. So beware of that one. We also have mentions of extracurriculars as best we could code. We have mentions of music or of arts. Yeah.
Jesse, are these basically just dictionary method, right?
Yeah. This is all dictionary method.
Reduce dictionaries based on reading a random sample of these things and apply the dictionaries to all of them.
Exactly. Actually, most of it was based not even on reading the letters, just on counting up common words and then thinking about, are there kind of themes that are common among these words? I didn't want to do too much of the reading of the letters, but okay. So this is summary statistics, which you definitely can't see, but the LIWC has things like achievement, effective, analytic, certain, clout, cognitive. They're things that you might think are useful for admissions, but they're general dictionaries that might not correspond to what people write in letters. What we came up with was academics, arts, extracurriculars, family, community, grit. Grit was things like determined or focus or effort. Humanities, language and culture, STEM, social sciences. A few people actually mentioned economics or politics in their letters, but it was the rarest one. Sports, a lot of people had mentioned a sport in the letter. And what we did is just counted the number of words in the letter that fell into each of these categories. So the average letter used 31 academic words and 5 sports words. The average letter had 440 words, 20 words per sentence. Obviously, there's variation around that. Yeah.
And these uses were literal, not say metaphoric, or you don't
I don't know. If there's a way, if there are natural language processing ways of distinguishing those, I don't know about them. But this is a new area to me. I'm very much a novice at NLP. So I did not read 20,000 letters, so I didn't code them that way. Some of these obviously are we worry more about them being metaphoric, but some of them are going to be pretty likely to be literal. But coach could easily have been used in a metaphoric way or a literal way.
And that includes repeated use.
It includes repeated use. So if the word soccer was used 10 times, they get a 10. Yeah. Okay. Okay. So then, just the first kind of question about these features is: are they reliable? Are they picking up the same students? So the fact that we have 2 letters for each of these students allows us to ask whether the students for whom letter 1 mentions a lot of sports are those the same students for whom letter 2 matches a lot of sports. If they're very different, then it's not clear we're going to get much power from categorizing students by what's in the letters, because there's so much variation among the letter writers and what they say about students. Turns out some things are not very reliable. So words per sentence, which I kind of thought would be a very useful proxy for how literary or literate the writer was, turns out to have 0 correlation between letter 1 and letter 2 within the same student. But word count, the length of the letter, is very highly correlated. I suspect that's kind of a proxy for whether you go to a school where the teachers, whether they all know that they need to write long letters or not. But I could be wrong about that. Future focus, tone, positive emotion are relatively unreliable, but power, drive, and achievement are pretty reliable. This is within the LIWC measures. If we then go over to the topic measures actually turned out to be more reliable. There's a pretty strong correlation between the number of mention of arts in letter 1 and letter 2, which I think is consistent with they really are capturing something about the students' interests.
That correlation is about 0.22.
Yeah.
It's hard to see that that's strong. It's the strongest that you've shown us.
Yes.
Then
So
it's-
you could think it's an eye of the beholder. I'm not sure how high I would expect it to be, given that these are just raw counts. And maybe there'd be a better way of calibrating that. But yeah, so you could say they're all weak, but that's the strongest. Humanities measures had basically no correlation. I think we just didn't get a great. It's hard. It was hard. History could mean lots of different things in a letter, and it's just hard to figure out whether they're actually talking about academic interests. Whereas physics probably is referring to the academic subject.
How much of these associations are just that these are kind of what the human brain, or maybe whatever, the letter writers, it's all the same. That is to say, when you write a letter of recommendation, these are the things you add. You have a human, and you put a couple of real things in there, but really, you have a job. I'm talking about the work of the letter writer.
Yeah.
And they fill those in. Maybe they have to write 20 letters or 7 or whatever. That's work.
Mm-hmm.
And they have a consistent method. So maybe you're reflecting that consistency between the two people.
It could well be.
We happen to have, Sharon, they both had this person in their class or whatever.
Right.
And so that similarity is right there, and it's just that's
Right.
a characteristic of the process, not
Yeah.
distinguishing important things of interest for these purposes.
So one thing we could do to try to get at that is try to look at these correlations among students coming from the same high school, where you think that are kind of the letter writers are have similar awareness of what problem they're trying to solve, and then ask whether they both identify the same student as being interested in sports. But we haven't done that. That's a good idea. Okay. So then the next question is, how do we use these to measure strength? And this is where the kind of tension between the prediction and the program evaluation is going to become a real issue. So I'll talk about that. But Evan?
I was just going to say on the last thing, it strikes me that in terms of strategy about whether or not who you pick to be recommenders, you might actually want a coach and a teacher to not talk about the same two things. It shows the breadth of. So you might call that unreliable, but in some circumstances might be advantageous for them.
Yeah, that's fair. That's fair. Okay. So now let me think about how I'm thinking about this prediction problem. What I'm interested in here is how much new information is the letter providing relative to what we already had in the application. Right? We already have a lot of information in the application. We already have things that I can observe: SAT, GPA, what high school you went to, various aspects of number of honors courses you took, things like that. There's also things in the application that I don't see, but that the readers saw, even without the letters. So the readers see the essays. And so one objection to the use of letters is, well, look, if there's an issue that a student overcame lots of challenges and we want to be able to recognize that in admissions, they could just write about that in their essay and we would capture that information. I'm a little skeptical of that argument because I'm not sure 17-year-olds understand that that's what they need to be doing in those essays. I'm not sure we communicate very well to the students, especially from non-traditional backgrounds, that they need to tell us about all the challenges they overcome so we can give them credit for that in their essays. And I do think that there's a chance that the letter writers can be more forthcoming about a student's background than the student can themselves, but we don't know. So it could be that that's also an aspect of this. So the way I'm going to think about it is that there's some set of characteristics of the application that I can see, non-letter characteristics of the application. I'll call those X. Then I can see the features of the letter L. The reader 2 sees X and L, but also sees another signal of the application quality Z, which I'm thinking of as the essays. There's a whole bunch of stuff about the application that the reader sees that I don't see. It could also be different combinations of characteristics I do see that I'm not able to capture. But I think it's easiest to think about that as the essays. There's some underlying strength of the applicant combining all of that stuff, which is Q. And I'm going to let Q of W be the best guess of Q given some characteristics of the applicant W. So what does reader 2's score represent? Reader 2's score represents the best estimate of the applicant's quality given X, Z, and L, because the reader 2 gets to see all of those. Reader 3 only gets to see X and Z, so they're going to give us the best estimate of the applicant's quality given those two. They don't have the letter. I only get to see X and L. I don't get to see Z. So what I'm going to measure is I'm going to try to come up with a proxy like Q of XL, the best estimate of the applicant's quality given both the SAT score and the letter, minus the best estimate of the applicant's quality given just the SAT score, Q of X. That's going to have two pieces in it. One is it's going to capture what I'm interested in, which is how much information does reader 2 get out of the letter that they wouldn't have had access to otherwise. That's the difference between the two reader scores. But another piece of it is that the letter is going to capture some characteristics that the readers could have seen without the letters, but that I couldn't see without the letters. So if you think of the letters are just saying the same information that's in the essays, that's new information to me because I don't see the essays, but it's not new information to the readers because they would have had that anyway. But that's going to show up in the way I can measure the letter's contribution. So that is to say that I'm going to find that the letter predicts the third reader's score, even though the third reader didn't get to see the letter. And that's true even conditional on all of the other stuff. And so then we have to think about what that means. And whether we want to call that the effect of the letter, I think no, because that was information that was already available to the letter writer. But, or to the reader. But it's there, and it's going to be important. So how am I going to approach this? I've got these two sets of features, X and L. I'm going to divide my sample of 10,000 observations in half. So I'm going to have roughly 5,000 applicants in a test sample and 5,000 in a training sample. In the training sample, I'm going to estimate 4 random forest models. One is just the third reader score on the things that the third reader should get to see, X. Of course, I don't see Z, so I can't include that, but of the non-letter characteristics that I see, I'm going to call that prediction S3. Then the second one is the third reader's score on X and L, which is S3 prime. Now, if I saw everything about the application that the third reader saw, that would be the same as S3. The letter wouldn't have any more predictive power. But in fact, S3 prime is going to be quite a bit different from S3, which suggests that there is information that the reader's seeing that the letter can proxy for, but that's not actually, the reader didn't actually need the letter to know about. Then I'm going to do the same too for the second reader score. The second reader does see the letters, so I'm going to give them an S2 and an S2 prime. And I'm going to construct 4 measures from that. One is S3. You could think of this as just a measure of how strong the application was without letters. This is our best estimate of the strength of the application given the things we can see in predicting the third reader score, who didn't see the letters anyway. The second is what's the difference between our prediction of the third reader score with the letters and without the letters? What that's capturing is how useful is the letter as a proxy for all of the things that the readers see that we don't see. Third is the difference between our prediction of the reader's scores just with X for the second reader and the third reader. What this is going to capture is the extent to which, on average, the second reader rates a particular type of student more generously than the third reader, because we assume, presumably because the second reader has access to the letters and the third reader doesn't. So if for example, soccer players get really good letters, much better letters than everybody else, then we would expect the second reader is going to rate the soccer players more highly than the third reader will. If soccer player is one of my X characteristics, then that will correspond to a positive difference between S2 and S3 for people with those X's. Okay? And then the fourth is going to be kind of the difference in differences among these. It's going to be the change in our prediction of the second reader score with the letters relative to without the letters, minus the change for the third reader. So there are two views about where our hypothesis or kind of question about underrepresented applicants might get weaker letters, where that's going to show up here. One view is it should show up in this fourth piece, delta. That if those students do better with the second reader than they do with the third reader, and we can predict that with these certain characteristics of the letters, then we should see a difference in delta between underrepresented students and non-underrepresented students. However, one of the things in X is most of these characteristics of underrepresentedness. Right? And so S2 minus S3, this is our prediction of the S2 reader's score on average given X, minus our prediction of the reader 3's score given X. If on average underrepresented students have weaker letters, then we should predict that reader 2's score should be lower for underrepresented students than it is for reader 3. And so we should see the difference in letter quality here. And so I'm going to be looking for underrepresented and non-underrepresented students in both of these. If this was OLS, if this was linear regression, not random forest, this coefficient, this would have mechanically zero difference between underrepresented and non-underrepresented students. We would be capturing it all here. But because the random forest is more complicated, we don't have this result that you get for OLS, that the best prediction of a rich prediction is the OLS coefficient with a smaller set of covariates. We don't have basically, let me put it this way. With OLS, S2 minus S3 has to be orthogonal to S2. But it's not true with random forest. And that can allow some things to show up here in the delta. Okay, so just to give you a sense of the distribution, on average, we assign the applications 3 for yes, 2 for possible, 1 for no. Here are the average predictions, so kind of 1.7 without the letter for reader 3, 1.8 for reader 2. It would be really worrying if the means were different with and without the letters, but it's not. But you do see the standard deviations a bit wider when you have the letters. There is some extra information in there. The standard deviations are somewhat lower in the test sample, because the random forest overfits a little bit in the training sample. But we still get a fair amount of reliability, it looks like, of these measures, of all of these measures, when we take it over to another sample. Okay? Although here's a better way to assess the reliability. Here what we've done is we've regressed the actual score on the predictions. So we should get coefficients of 1. And in sample, you get coefficients of 1 everywhere, just about everywhere you're supposed to, although the delta kind of has a bigger coefficient. It's a little over-shrunken with the random forest. Yeah. 5,000 applications, so it's actually 10,000 observations because we divide in 2 with the 2 letters. Okay? Well, okay. Actually, no, this is 5,000. We averaged the 2 letters. But okay, and then the training sample, here's the test sample. Here, the coefficients might not be 1 if we're overfitting, and you definitely see that some of these, the difference between with and without letters is not as reliable as you'd like. It doesn't have a coefficient of 1, but there's still some. It does look like it has some real signal. Same with D2. And when we regress the difference between the reader 2 and the reader 3 score on this difference in differences with the letters and without, we do get a coefficient of about 1. But when we put all the stuff in, things get mushy and kind of flip sign. And so I'm not quite. I think what's happening is we're kind of overfitting a little bit in this difference in differences strategy, or overfitting quite a bit. Okay. It's kind of interesting to see what predicts these different things. So if you just try to predict the reader 3 score, you ask how much better is the reader 3 score for certain character. We take the reader 3 score with the letters, predict the score with the letters and without the letters, take that difference, and then correlate it with letter characteristics. You see that that's pretty strongly correlated with whether we had letters, with the number of letters the students submitted. It's correlated with the kind of number of mentions of academic words, with the length of the word, with grit, with family and community, with kinds of things that you might expect letters to be telling you about, that you might expect a strong letter to be telling you about, extracurriculars. The kind of LIWC measures of kind of future focus or cognitive or power really don't seem to have much relationship. We're capturing more of it with the topics. But the same thing is true. We see the same pattern for reader 3 and reader 2. This part can't be what the letter is telling the reader, because this reader didn't have the letter. So what this is telling us is when the applicants read letters mention academics more, that's a student who the reader is going to be able to tell is strong even without the letters in ways that we can't capture with the kind of observable measures we have. This graph for reader 3 is pretty similar to reader 2. When we take the difference between those, we get much smaller variation. And so we still see the same general pattern, that this difference in differences is correlated with letters received and academic topics and word count, but it's much more weakly. And then I am running longer than I thought I would, so I think I'm just going to stop with this last slide, which is how different are the letters that URM applicants get from non-URM applicants. So here is the difference in means of each of the letter characteristics for the underrepresented applicants and the non-underrepresented. Underrepresented applicants' letters are much less likely to mention STEM. They're much less likely to mention arts or past focus, academics. They're more likely to mention present focus, drives, or clout or power. Some of these I would have expected, and some of these I really wouldn't have expected. I don't know how much to attach to my expectations, but that's what we see. But of course, these are raw differences in the letter characteristics. Much of this the reader probably already knew without the letter, because there's a lot in the application that might have proxied for academic focus or STEM, and they might not have needed the letter to know that this was not a STEM-focused student. And so let me skip over this. Here's the difference in the different measures of the application strength between URM and non-URM students on average. And I've done it for the full sample, and then I've done it for everybody who had a predicted probability of admission above, I think, 0.05. So throughout the people who had basically no chance of getting in, and focus on the people who had a chance. And what we see is that all the strength measures are weaker for the URM students than for the non-URM students. The URM applicants have lower SAT scores and lower GPAs on average than the non-URM students. And so that's what this is picking up, this S3. And it's not much, and it gets a little bit lower when we give the letter information, even for reader 3 who didn't have the letters. So again, conditional on the SAT score and the GPA, there's things that the reader 3 can see about the applications that are weaker on average for URM students and non-URM students, and that are proxied by these letters. So that's about a 0.08 difference on average. But it's exactly the same for the reader 3 and reader 2. And so one measure of the average difference in letter strength is S2 versus minus S3. That's this plus 0.017. That's what we kind of saw in the program evaluation approach, which is that on average, the reader 2 gives underrepresented applicants a higher score relative to reader 3 than they do for the non-underrepresented. That's what's captured here. And then if you try to look at the new information in the letters, it doesn't look like that's changing the story. Now again, this is kind of mechanically needs to be true, but it's not actually mechanically true because it's not OLS. But there's a sense in which if the models were working well, all of the differences between URMs and non-URMs would show up in S2 minus S3, not in delta. But the upshot is the same. It looks like the letters are a bit stronger on average for the URM students than the non-URM students, where stronger is defined as whatever it is that makes a reader give the applicant a higher score. And the story is basically unchanged when you focus on the marginal applicants. So I think I will, since I'm out of time, I will stop there. And just say, if you come back to the primary question about whether the inclusion of letters helps or hurts minority applicants, not racial minority, but underrepresented applicants, the program evaluation perspective suggests that it hurts some of them because they don't return letters when they're asked, and it helps others because if they do return letters, they seem to do a better job. They seem to get better scores, and that second effect seems to be bigger than the first one. So the net effect is a small positive. The natural language processing does suggest that we can measure aspects of the letter strength, but the letter strength is not surprisingly very strongly correlated with the non-letter aspects of the application. And so it's pretty hard to isolate what the letter is contributing relative to other things. To the extent that we do, it looks like if anything it's the same or maybe a little bit favors the underrepresented applicants. So it's a similar story to the program evaluation perspective. The inclusion of the letters looks like it raised the underrepresented share a very small amount. Turns out, actually, I didn't show you, if you control for other application characteristics, I'm not sure that I can find any average difference in the letter characteristics that I can measure between URM and non-URM students. If I try to predict whether this application was from a URM student using all the X's and then using X and L, the extra piece seems to have zero reliability. So it doesn't look like the letters are all that different after you control for the other stuff. Interestingly, that's not true for gender. If I try to predict whether this was a female applicant using just the X's or the X's and L's, that extra piece does capture something about, I can predict whether this is a female applicant reliably. It doesn't look like that's very strongly associated with the strength of the letter, but I think one thing I want to do is follow up and see if I can learn something more from how those letters are different. They're not very well they don't line up all that well with what I would have expected. You might have thought that there'd be more mention of kind of family and community in girls' letters relative to boys, and it's actually the opposite of that. But you can also imagine that the letter writers know that people are looking for certain things and try to offset those expectations. So I'll stop there. Thank you. I guess we have a Q&A time.